The integral of e to the negative x from 0 to infinity is easy to evaluate if we understand the definition of an improper integral like this. To evaluate an integral with infinity in the upper bound, we need to take a limit. We'll replace that upper bound with, say, b, and then take the limit as b goes to infinity. So this improper integral, if it exists, is defined to be the limit as b goes to infinity of this integral. So we've just replaced infinity with a finite number that we allow to tend towards infinity. To evaluate this limit, we should first actually do the integral. Now we have a very ordinary definite integral inside the limit expression, so let's integrate e to the negative x and evaluate with these bounds. The integral of e to the negative x is negative e to the negative x, and if we plug b into that, we get negative e to the negative b. Then we subtract, plugging in the lower bound of 0. So subtract negative e to the 0. And again, we're taking the limit of this as b goes to infinity. So let's think about what's happening here. Minus negative e to the 0 is, of course, just plus 1. But what about negative e to the negative b? Well, as b goes to infinity, we have e getting an arbitrarily large negative power. We could rewrite that as negative 1 over e to the b, and clearly as b goes to infinity, this denominator is getting arbitrarily large, and so this expression is going to be approaching 0. It's negative 1 divided by an arbitrarily large number. Hence, the limit is just 0 plus 1, and so it's equal to 1. So the integral of e to the negative x from 0 to infinity does exist, and it is equal to positive 1.